Hey everyone, today we're going to start our unit on vectors. Today's lesson is intended to give you some background information, sort of the basic concepts of vectors. Make sure you have your note sheet with you so that you can fill it out. I'm probably going to have to split this up into a couple of videos, but we'll see how it goes as we move along. So let's start with some basic definitions. Let's talk about a vector. A vector is a quantity that involves both a magnitude and a direction. So for example, you'll see written there, it says pulling a cart up a 30-degree incline, requiring a certain amount of effort. Right? So that is a vector. It has both magnitude and direction. A scalar is something that has only magnitude but no direction. So for example, the temperature of a room is 68 degrees. So that would be an example of a scalar quantity. So if you want to pause the video and make sure you can write those down, and then you can start the video up again when you're all set. Okay, directed line segments and geometric vectors. So the idea behind this is that now we can take a line segment and assign it a direction, and we then have a directed line segment. And we can do that with simple notation. For example, if I were to draw this line segment, this is the line segment PQ. Right here is my initial point, the start of the arrow. Initial point, the start of the arrow, and then the terminal point is the end of the arrow. And that tells you the direction that your vector, or excuse me, that your line segment is going. Okay? When we write it to use for whatever purposes, then that arrow above the letters follows the direction of the arrow above the letters in our drawing. So that's how you can tell the initial part of the line segment and the terminal part of the line segment. When we talk about magnitude, that is basically talking about its length. So the magnitude of a directed line segment is its length. So if you want to make a little note there, that magnitude and length, they're synonymous. You can use them interchangeably. They mean the same thing. Okay, and so when we talk about it, because we're talking about length, you can't have a negative distance. We talk about it in the absolute sense. So we're always talking about absolute value, but when we talk about it, we have these double bars. Okay, and that's how we represent the magnitude when you see these double bars. When we are talking about, and this is just a little bit about notation, when you are talking about a vector per se, you'll see in print, usually just in print it'll just be a bold letter, but when we write it, we put an arrow over it to signify that it's a vector. So if you look in your book or when you're doing the homework problems, you won't necessarily see the arrow over it. You'll just see a lowercase letter that's in bold. That's a vector, but when we write it, we put the arrow over it. Okay, so V is the same as PQ. They're both vectors, and that's how we would write it. Magnitude, when we write it, we would write it like that. In the book, though, it wouldn't have the arrow over it. Okay, so that's just a couple of things. Now, let's talk about relationships between vectors. I kind of wrote all over the page here, so hopefully you can find a little bit of room somewhere. But we have actually 4 different scenarios when we're talking about vectors. Vectors may have the same magnitude and the same direction. If they do, they are said to be equal. Okay, they're equal if they have the same magnitude and the same direction. However, though, they can be equal if they have the same magnitude and same direction, but they might have the same magnitude but different directions. Okay, so if they're equal, they have this, let me change colors, they have the same magnitude and direction. So for example, these 2 vectors would be equal. I'll call this V and I'll call that W. Those are equal. They have the same magnitude and same direction. However, I could have this vector V and this vector W, which they're equal in length, but they're going in opposite directions. Okay, so they do not they're not equal vectors. They have the same magnitude but different directions. They may be going in opposite directions. They might be going askew. Maybe you have this one V and this one W kind of going in opposite, not opposite directions, but different directions. Okay, so those are just some examples of how you might have vectors. You might actually have vectors that are going in the same direction but have different magnitudes. So for example, here's V and here's W. They're going in the same direction but they have different magnitudes. So when we're talking about equality in terms of vectors, they have to have both the same direction and the same magnitude. Otherwise, we do not refer to them as equal. Okay, so let's go on to the bottom of that first page there. And it says, you know, two vectors are equal. They have the same magnitude and same direction. We just said that, but let's go ahead and prove it. If you see here, we've got two vectors. I'll call this vector up here, I'll call this U, and I'll call this one V. Okay, so those are my two vectors. And if I were to go ahead, I put in the points already, the initial and terminal points of my vectors. I have the coordinates of those. So I went ahead and put those in. And let's go ahead and find the magnitude of those vectors. So let's talk about the magnitude of U first. And all we're going to do is use the distance formula. And when we do the distance formula, right, I have x, the difference in the x's squared plus the difference in the y squared. And if we went ahead and figured that out, right, that would be the square root of -5 squared plus -3 squared, which would then give us the square root of 34. If I went ahead and found the length, or the magnitude, of vector V, I would have 1 minus 6 squared plus -1 minus 2 squared, which is going to give me also square root of 34. So I've just shown, or I've just proved, that both of my vectors have the same magnitude. How do I prove that they have the same direction? Find the slope. So find the slope of each of them. So let's find the slope of U. If I find the slope of U, I'm just doing change in Y over change in X. So 3 minus -2. And that would give me 3 over 5. And now I'm going to do the same thing for the slope of vector V. And that's going to give me 2 minus -1 over 6 minus 1, which will also give me 3 over 5. So they have the same slope, they have the same magnitude, and by that I can say that those vectors are equal. So therefore, that's what those 3 dots means. Therefore, those vectors are equal. Okay, so you have to be able to show both. Okay, a vector, if we go on to the next page, a vector can be multiplied by a real number. Magnitude changes when we do that, but the direction does not. Okay, so when we multiply by a real number, we change the magnitude, but we don't change the direction. All right, so for example, let's say I have this vector, pretend that's a straight line. Suppose I have this vector V. Well, if I multiplied it by 2, I would now have this vector. Notice my direction didn't change, but I just doubled the magnitude of my initial vector. I can also take half of it. Maybe I don't want as long a vector, so that would be 1/2 V. Okay, so you do not change the direction. However, if you multiply by a negative number, you're going to reverse the direction. Okay, so if I then had this, and that should be a straight line. Of course it's not, but that would be equivalent to negative v, right? Because I multiplied it by -1 and I changed the direction. When we talk about multiplying by a real number, that's called a scalar multiple. So then we note that with the letter K. So KV is called a scalar multiple. This is a scalar multiple of our vector v. Whoops, the magnitude then of our vector we take the absolute value of k and then we take the distance of v. Okay, so that's how we find the magnitude of our scalar multiple. Remember that when we're talking about magnitude, we're not talking about negative numbers. We're talking about length, and length can only be positive. If you multiply by a negative number, it just changes the direction, but it doesn't change the length or the magnitude of the vector. Okay. Let's talk about addition and subtraction of two vectors. You probably hear this term tip to tail. I'll write that in here. Tip to tail. Tip to tail. Basically, it's a representation of adding vectors together. So if I have this vector u, this is my vector u. This is my vector v. Then this vector here is u plus v. So tip to tail, because once you have one vector, you start at the tip of that vector with the tail of the second. So that's why it's called tip to tail. You have one vector from the terminal point of that vector, from the tip of that vector, you start the tail of the next vector. And wherever you end up, you start at your initial point of the first vector to the tip of the second vector, the end point of the second vector, and that gives you your result. Okay, so that would be u plus v. Now, if you wanted to do u minus v, so let's say this is your u, and you wanted to do u minus v. Well, minus v changes the direction, right? So minus v would put you this way. Minus v would put you this way. And so you end up u minus v. Okay, so that's the idea behind that. And I am going to go ahead and pause the video there. I'm actually, just because I'm running out of time, I'm going to revisit the subtraction part in the next video to talk about it in a little bit more detail, because I'm going to try explaining it a slightly different way, because I'm not sure if that totally makes sense the way I did it. So catch me at the next video and we'll go over that part again. Thanks, everybody.